everyone! Last time, we talked about the first 6 theorems. Now, we are going to talk about the remaining theorems. Theorem 7, 8, 9, 10 up to 15. Also, we will discuss about the hedgerows and theorem 16 up to 18. So, please sit back and relax, and I hope you'll enjoy this video. Theorem number 7. Two lines perpendicular to the same plane are parallel. We have here two pillars. This pillar here in my left hand, and this pillar here in my right hand. These two pillars are both perpendicular to the ground, which is our plane. And when we say perpendicular, meaning they are upright. They stand upright. So, according to the definition of parallel lines, two lines which do not intersect are parallel. So these two lines did not intersect. So therefore, these two pillars are parallel.
Theorem number 8. If a straight line is parallel to a given plane, it is parallel to the intersection of any plane through it with a given plane. So, to illustrate that theorem, we have the edge of the door here as our line, and this wall here as our plane. So, as what we can see, this line here and this wall here, should I say, the plane here, are parallel to each other by the relative positions of a line and a plane. Next is, we have this door as our another plane that intersect our wall, which is our another plane, through our line. And we have this line as our intersection. So by theorem 1, we all know that two planes intersect in a line or through a line. So we have here to prove that this line here, which is the intersection of the two planes, and the line here are parallel to each other. We should say that these two lines here determine this door, which is provided by theorem 2 that a line can be determined by a line and a point not on it, by two intersecting lines, and by two parallel lines. That is, it is very much obvious that this plane here is determined by these two parallel lines. Thus, this intersection here and this line here are parallel to each other. Theorem number 9. If each of two planes is perpendicular to the same line, they are parallel. The theorem number 9, we have the floor here and the ceiling above as our two planes, and this pillar here as our line, which is perpendicular to our both planes. So, as we know, this pillar is perpendicular to our floor, so it makes an angle which measures 90 degrees in this side. Same with the ceiling above. This pillar here inscribe a 90-degree angle there. By corresponding angle postulate, by the way, do you know what corresponding angle postulate is? Corresponding angle postulate states that if two parallel lines are cut by a transversal, the corresponding angles are equal. Thus, this line here serves as our transversal, and since a plane consists so many lines, infinite lines actually, that passes through this foot of perpendicular. So we all know that they have the same corresponding angles, thus the two planes are parallel to each other.
Theorem 10. If a plane is parallel to each of two intersecting lines, it is parallel to the plane of these lines. Okay, we have here this ceiling and this floor as our two planes. And this ceiling and our floor is parallel to each other. Referring to theorem 2, a plane is determined by two intersecting lines. Our ceiling here has two intersecting lines. This line and that line there. And these two lines intersect at that point. So therefore, this floor is parallel to the two intersecting lines that determines the ceiling or our plane.
Through a point not on a plane, there is one and only one plane parallel to this plane. So to illustrate that certain theorem, we have our floor as our plane and the light bulb above as our point. So as what it is parallel to our floor is the ceiling, which is through our point, which is our right bulb.
Theorem 12. Through one of two skew lines, there is one and only one plane parallel to the other line. In this theorem, I mentioned about what is skew lines. By the way, what is skew lines? Skew lines are lines that are not parallel but they do not intersect. For example, that line there and the line there are the skew lines. They are not parallel and they do not intersect. Going back to the theorem, it says that one of that skew lines are parallel to the plane. Let's take, for example, this floor as our plane. And our skew lines are that line and that line. So, it is obvious that that skew line is parallel to our floor. Theorem 13. Through a point outside of each of two non-parallel lines, there is one and only one plane parallel to both of these lines. Okay, let's take these lines here as our example. This line here and this line here, they are not parallel. And our point is this chandelier. Okay, and we have given plane which is our floor. And it is obvious that our floor is parallel to these two non-parallel lines, which is this line and this line.
Theorem number 14. If two intersecting lines in one plane are parallel respectively to two intersecting lines in another plane, then the planes are parallel and the angles formed by the lines are equal. So to illustrate that theorem, we have here these two lines, this line and this line, which determines this plane, and we have here another line, this line and this line, which determines this plane. So as what you can see, the line and this line, they are parallel to each other, and in same manner, the plane determined by this line and the other plane determined by those lines are equal. I mean, they are parallel. And on the other hand, the angles formed by these lines and the angles formed by those lines are equal. Theorem number 15. If two lines are cut by three parallel planes, the intersected segments in one line are proportional to the other. So, to illustrate that certain theorem, we have here these two lines, this one and this one, and we have here our three parallel planes which are our geodesics. So we have here this plane, and this other plane. So as what you can see, these three planes cut our two lines. So the intersected segments, which is this one, is proportional to the intersected segments on the other line, which is this one. So the intersected segments here and the other, which is here, are proportional to each other. And now, everyone, we have come to the point that we need to explain what the header angles are. Many of us may not be familiar with the header angles, but it is very much astonishing to note that the header angles is around us. They could be very much useful to us, or you might just see them every day. So to explain what the header angles are, actually, they are just angles which is formed by two intersecting planes. These planes could be two half planes, two full planes, or the other one is half and the other one is whole. So to illustrate what the header angles are, we have here this plane here and the other plane here, and they intersect through this line. So the angle formed by these two planes here is the dihedral angle, and this line here is their common edges. I mean their common edge. To name a dihedral angle, we need first to consider the name of this plane, the name of this edge, and the name of the other plane. So suppose this plane here is plane M, the line here is line AB, and this plane is plane N. So the name of our dihedral angle would be M-AB-N. It is very much interesting to note that dihedral angles could be right angles, and if the dihedral angles is a right angle, like this here in our example, if the angle formed by these two planes is a right angle, the planes are mutually perpendicular to each other. Furthermore, plane angles could be obtuse or acute.
A while ago, my partner talked about what is the dihedral angle. Now we are going to use those dihedral angle to prove our theorem number 16. Theorem number 16 states that two dihedral angles are equal if their plane angles are equal. So we have here the floor and this wall. This wall and the floor forms a dihedral angle, which is this angle. And second is this. The second dihedral angle is this wall and the ceiling. And their dihedral angle is that edge. Suppose that this wall and the floor forms a right angle. Also the ceiling and the wall also forms a right angle. So, by sensitivity, these two dihedral angles are equal. So therefore, their plane angles are also equal.
Theorem number 17. If two planes are mutually perpendicular, and if a line is drawn from one point in one perpendicular to their line of intersection, this line is perpendicular to the second plane. So to illustrate theorem number 17, we have this wall here as our first plane and our floor as our second plane. So these planes are mutually perpendicular to each other if and only if they form a right angle, and in this time the right angle form is here. And we have this stellar as our line, which is drawn from this plane through the second plane. So given that this plane is, as what I've said, perpendicular to the second plane, it is very much obvious that this line here of our first plane is perpendicular to the second plane. Theorem number 18. If a plane is perpendicular to each of two planes, it is perpendicular to their line of intersection. So we have here our floor as our plane, and this wall as our another plane, and this wall as our third plane. Suppose this wall here and the other wall here intersect, and by theorem 1 they intersect through a straight line, which is this stellar. Given that this wall here is perpendicular to our floor and the other plane here is perpendicular to our floor, which is given, it is very much obvious that their line of intersection, which is this stellar, is perpendicular to our floor.